How to use 3D LOC. In this video, I will give you an introduction to Inspection Robotics' new 3D LOC software. We are using the bike platform with the 3D LOC module and the TZ1 HD inspection camera. If the robot is connected, the software shows 3 window segments. On the right, there are the camera views, the front and back navigation cameras and the inspection camera. The 3D scene is initially empty. To start an inspection, we need to create a new mission. First, we need to assign a new file name for the mission file. All inspection data will be stored in this file. Now the software lets us enter some additional information to describe the inspection job. It is usually a good idea to enter information about the asset, the customer, and the equipment at this time, even though it can be entered or modified also at a later stage. Now we need to select the type of asset model we want to use. In this case, the model was created by Asset Builder. With the Load button, we can select the correct STL file. We then use the 3D preview to verify that the correct model was selected. For complex models, Asset Builder lets you generate a light version. If the light model is named correctly and located in the same folder, the software will automatically find it. Otherwise, we can locate it manually. If the triangle count is marked good, we can proceed with the OK button. When the model loads, the robot is placed at the coordinate origin. We now need to place it where it is actually deployed, in this case at the opening of the pipe. We rotate and cut the model to have a good look at the deployment location. Then we select the correct camera position from the Settings menu. Now we can place the robot using the Place Robot icon. Clicking in the area of deployment will let the system automatically place the robot correctly. If the shown laser beams terminate at the model boundaries and the robot is placed as expected, we can confirm the placement. The 3D scene is touchscreen friendly. We can rotate, translate, and resize the model. The 6 clipping planes can be used to look inside. The blue handles can be scaled by holding the right mouse key. If the robot is in brake mode, the inspection camera movements are controlled from the joystick. When moving the camera up or down, the 3D view shows the field of view. We can configure what is shown by the 3D scene. The view can be reset to either of 4 standard views. With the visibility icon, we can select what elements should be shown. Note that the robot can be placed again during a mission at any time. We use the Cycle Views button to bring the inspection camera view to the main scene. Several camera positions can be stored for quick access. For instance, to move to horizontal, we only need to click on Go to 0 pos. The camera lights and the 2 laser dots are directly controlled from this view. The zoom is either controlled by the joystick or by directly clicking the plus and minus buttons. Note that the camera cone in the 3D view adapts to the zoom level. The camera can be moved up and down from the joystick by clicking on the image or by the arrow buttons located below the camera frame. Focus control is set to automatic by default but can be directly controlled if necessary. When doing inspections, the full screen view provides a higher resolution image. Note that we can still move the camera up or down by clicking on the image. Before moving the robot, we bring the front navigation camera to the main scene. When driving the robot, it is recommended to permanently observe the navigation camera view. The illumination of the navigation cameras can be controlled from 2 sliders on the right. Note that the boost mode increases the light intensity but should only be used for a short time to avoid overheating. It automatically deactivates itself after 5 minutes. The navigation cameras are set to auto exposure, which can be deactivated if required. For additional documentation purposes, we can take still images or record video from both navigation cameras. This data will only be stored locally and will not be part of the mission file. When driving backwards, the back camera should be used. For inspecting a feature, we use the 3D view to localize it and then switch to the inspection camera view for a more detailed view. To capture the view, we can either press the blue button on the joystick or switch to the 3D scene and click on the Capture button. In the Capture dialog, we can enter details we want to record concerning the captured image. Note that this information can also be modified later. If for some special purpose an image needs to be saved separately, the Save As button can be used. This will create an extra file stored only locally and not as part of the mission file. There is also the possibility to draw or write annotations directly on the image. Once again, if for some purpose an annotated image needs to be saved separately, the Save to File button can be used. This will create an extra file stored only locally and not as part of the mission file. Finally, when clicking on the Save button, the image is stored to the mission database together with the location, the robot position, and the camera settings. This completes the capture. For moving the robot, it is recommended to zoom fully out on the inspection camera and to bring the front navigation camera to the main scene. By releasing the brake from the joystick or by clicking the brake button, the robot can be moved to the next point of interest. We now repeat the process of inspecting a feature, this time using a camera test pattern mounted on the back wall of the pipe as our point of interest. To increase the image quality, it is recommended to illuminate the area as good as possible. We use full screen mode to verify the image quality. Now we trigger the capture by using the blue button on the joystick. This time only a title and a location is entered before we click the Save button. Now we have stored a second capture to the mission database. In the 3D view, we can now see that a marker appeared on the back wall of the pipe. It represents the center point of the image we just captured. Note that also the path by which the robot moved is shown as an orange trace line. The visibility of the markers and the trace can be toggled from the visibility icon. If we slightly change the view, we can see that there is also a marker for the first capture we made. Once again, for driving the robot, we zoom out on the inspection camera and bring the navigation camera to the main scene. To steer the robot over an edge, it is important to align it properly by using the navigation camera. From this position, we can get a different view at the first feature we captured. Let's capture this as well. After we steered the robot over the edge into the small diameter pipe section, we can have a look at the angle displays on the right. The steering angle indicates the position of the front wheels with respect to the robot. The gimbal angle indicates how much the front axis is tilted. This angle is mechanically limited to 27 degrees. If the angle approaches the mechanical limit, the robot should not be moved any further or we risk losing surface contact. When driving backwards, we switch to the back navigation camera. In order to better judge how the robot is placed, we use the 3D view. Before we move the robot out of the pipe, we take one final capture of the weld seam just above. This leaves us with a total of 4 captured images which can be included in the inspection report. How a report can be created from a mission file will be shown in the next video. Thank you for watching.